Hi guys, this is Mr. Mfega from Sivelile High School here. I thought maybe I could or I might just help you with the same two topics basically while you're at home, since we're going through, the whole world is going through this whole thing that's making you stay at home for this period of time. Now, the term 2 has got actually three topics. It's the analytical geometry, functions and inverses, and lastly, the calculus, differential calculus. Now, for analytical geometry, we strictly focus on the circular geometry. By the way, I'll make 3 videos. This is the first one. The first one, I'm going to be looking at the revision for analytical geometry in grade 11, grade 10, and earlier grades. Now, then the second one is going to be, that's when we're going to start with the circular geometry. But in analytical geometry, grade 11, grade 10, the things we looked at, you probably remember most of the things we talked about in those grades. Firstly, we talked about the average gradient, where we said this is the formula for average gradient. So if you want to find a gradient between 2 points, it's changing y over changing x. You just have to make sure that because we obviously know that you could start with either point. You're not restricted. You do not only or specifically have to start with b. If you've got y of b minus y of a, so it's gotta be x of b minus x of a. If you've got y of a minus y of b, then for x values, it's got to be x of a minus x of b. And we also talked about the distance formula, where we said if we want to find the distance between 2 points, given the coordinates of those 2 points, then it's the square root of the sum of difference between the y values, the square of the difference between the y values plus the square of the difference between the x values. For this one again, you have to do the same thing. If you say y of b minus y of a for x values, it's gotta be the same thing. Do not make a mistake of saying y of b minus y of a and x of a minus x of b. I hope this one is clear, guys, because we do know these things, but we don't end up making silly mistakes that might lead us into getting the wrong answers. For number 3, we talked about the midpoint formula. We said if we want to find the midpoint between 2 values or between 2 points, it's actually half of the sum of x values and the y values. Remember that the midpoint has to be written as a coordinates because that's a point. So hence why it's half of the sum of x values versus or mapping the half of the sum of the y values. Also, it's also important to know that for the midpoint, you could also write the midpoint formula in this fashion. Well, it proves most of the time very, very, very useful writing it in this fashion. If you write it as x of m, if m is the midpoint, x of m being basically we just break down the midpoint formula, but writing it as the subsections for the x value of the midpoint and the y value of the midpoint. We'll see as time goes on how and where or when that helps. For number 4, we talked about the inclination of an angle, where we said to find an inclination a certain line makes with the positive x-axis, we say tan theta equals m, where theta is between 0 and 180. Now, I want to emphasize, guys, that if you find the angle of inclination, you find the angle that a line makes with the positive x-axis, guys, because in mathematics, angles are positive moving in an anti-clockwise direction, taking the positive x-axis as the reference point. If you write a Cartesian plane, you have 0 on the positive x-axis, 90 on the vertical line, at the top 180. So we take the positive x-axis as the reference point, because at times you'll find that you want to find an angle of inclination where that line has got a negative gradient. So you basically have to add 180 on this one. I will not go into details as to why, because my assumption is your teacher probably did explain that in grade 11. And number 5, we talked about the equation of a straight line, and we did say that we could use either of the two, y equals mx plus c, or y minus y1 equals m into x minus x1. So if you have a gradient, then you need at least one point from which the straight line that you're finding an equation for passes through. Then you can find the equation that you're looking for. If you're not given a gradient, obviously you have to try and find a way of firstly finding the gradient, then find the equation. Also, we say if you want to find the equation of a straight line that is a constant, a vertical line, x is equal to k, where k is a constant, or if it's a horizontal line, y is equal to k, where k is a constant. So basically, if you are given two coordinates and they ask you to find the equation of a vertical line, you just look for the x value of those coordinates. Then that becomes the equation of the vertical line. If they want the horizontal line, the equation of the horizontal line, so it's gonna be y equals the other value. In this case, it's going to be x. If you want the one for a vertical line, you use the x value. If you want the one for a horizontal line, you use y. Then number 6, we also looked at the gradients, the relationship between gradients of certain lines. So we said the gradients of perpendicular lines, we said their product is equal to -1. The gradients of parallel lines is actually equal. Sorry about this one, it should have been, this is to say M1 is equal to M2 or M3, depending on how many lines that are parallel you're given. So let's look at the example, guys, that's gonna remind us about some of the things we've just been looking at. The example here says, in the diagram below, A with coordinates x versus y, B with coordinates -7 versus 3, and C with coordinates -5 versus 6 are vertices of triangle ABC, with E being the midpoint of AB and DB is a vertical line. Well, I also have to stress or emphasize that these diagrams are not necessarily drawn to scale, guys. This diagram is not necessarily drawn to scale, and well, my drawing is very horrible, because if you look at E here, there's no way this could be the midpoint of AB. So just assume that the information in the statement aligns with the diagram. Now the first question here says, determine the coordinates of M, which is the midpoint of BC. Now I usually tell my learners to always read this statement completely, try to make sense of the statement, then try to answer the question after having understood. Enzo, me, sorry about that, guys. Then, so this question says determine the coordinates of M. You clearly cannot see where M is in this diagram. Sorry, guys, I just had to attend to my kid. I want you to, every time I show you a question, I want you to pause this video, try to do the question, and then before actually looking at the solution, try to see if the answer that you arrived at aligns with the solution. I hope you've paused this video. Now we'll come back. So here is what the solution looks like. The midpoint of BC, so we use M for midpoint, so the x of B plus x of C all over 2 is 2, y of B plus y of C all over 2. Then you make your substitution. Now I want to stress the importance of employing the brackets, guys. Whenever you substitute a negative value, always employ the brackets, because then for this one you might argue and say, but say we have a plus, why do I have to put in the brackets? The problem is gonna start when you have a formula that's got a negative in it, and you substitute something that's negative. If you do not substitute the brackets, you might end up making the mistake of assuming that the negative is already there, and you end up having something that's actually wrong. But I hope you got the answer. Now let's look at the second one. B says determine the coordinates of D. Now if you look at this diagram here, the coordinates of D is clearly, firstly, the value of y for D, because these are axes. D is actually on the x-axis, which means D is the y-intercept. If it is the y-intercept of that line, then your y is equal to 0 at that point. Also, if that is a vertical line, which is, by the way, parallel to the y-axis, it means your x value is the same throughout, so it's -7. So the coordinates of D is going to be -7 versus 0. I hope you pause the video before actually trying to find the solution. Now the second one, I'm sorry about the statement I just said to you. I hope you pause the video before looking at the solution. Pause the video, do the solution, and then look at my solution. Now the coordinates of B, I said it's -7 versus 0. I only wrote the x value of point D, but I hope you arrived at the correct answer. For C, show that coordinates of A are 5 versus -1. I want you to pause this video and actually think about this and try to do it before you look at the solution. Here is A, guys. In the statement, you're told that E is the midpoint of AP, and we do not know the coordinates of A, but they've given you the coordinates of E as well as those of B. Now, using the midpoint formula, this piece of information I talked about here earlier, you use this one because you know instead of E, you're gonna have E, because x of E, that is gonna be the midpoint. E, they said to you, E is the midpoint, so you're gonna have x of E equals x of A plus x of B all over 2, and y of E equals y of A plus y of B all over 2. Then you make your substitution. I hope you arrived at this answer. So if you do your proper substitution here, also I want to bring your attention to this one. I employed the brackets because I substituted a negative value. So you're gonna have, if you manipulate this formula, you times by 2 on both sides, then add 7 on both sides, or alternatively, usually you guys like saying you transpose. So fine, you transpose -7, so you're gonna have -2 plus 7, which gives you 5, and you do the same thing for y to find y of A. So if you write that as coordinates, your A becomes 5 versus -1. For C, for D, if F is with coordinates 7 versus 2, show that AF is parallel to BC. Let me show you the diagram again. Here's the diagram. We do not know where F is. You cannot see F in the diagram, but if they say to you F is with coordinates 7 versus 2, those values are both positive. Clearly, that's somewhere in the first quadrant. So that's something that could be anywhere around here. if you think about it, guys, that somebody who's doing mathematics, you can visualize this. You can see that it's going to be somewhere around here. So what you have to try and do, find the gradient of AF, find the gradient of BC, and then see if those two gradients are the same, because we said the gradients of parallel lines are equal. So if they say to you, prove that AF is parallel to BC, then using their gradients, they've got to be the same. So I hope you've paused the video and try to find the gradient of AF as well as that of BC, and then you arrive at something that looks like this. You can clearly see that you write your formula, your correct formula, you do your correct substitution. Once again, you employ the brackets here, so you end up with 2 minus into negative 1, which actually gives you 2 plus 1, which is 3. 7 minus 5, it's 2, so the gradient is 3 over 2. You do the same thing for this one. Do your correct substitution, you arrive at 3 over 2. So clearly you can see if the gradient of AF is 3 over 2 and that of BC is 3 over 2, then since their gradients are the same, then AF is parallel to BC. That's how you conclude. For E, it says here, determine the length of AB and hence the length of AE. Now, the length of AB, let's look at the diagram again. You do know the coordinates of B. You've just been asked to find the coordinates of A. Now, use that piece of information to find the length of AB. Pause the video, guys. Use the correct formula to find the length of AB. I hope you arrived at something that looks like this one. If you do your correct substitution, then your AP becomes 4 to 10 units. I wanna also talk about the importance of writing that units, because we do not know if the length here is in centimeters, meters, millimeters. So we generalize and just write units, guys, because this is the distance. For Roman figure 2, the length of AE, I know you know the coordinates of E. Somebody else could have said, okay, I know the coordinates of E, I know the coordinates of A, then I could use the distance formula to find the length, which will give you the same answer or the correct answer. But if you think about what it means to find the midpoint, if they say E is the midpoint of AP, then you know that AE is actually exactly equal to BE. Now that would mean AE is half of AP, which is why you end up with 2 root 10 units for AE. For E, it says determine the inclination of EP and hence the size of angle B1. Determine the angle of inclination of EP and hence the size of B1. Now, if we look at the diagram again, there's your B1 here. But firstly, to find this angle, they said first find the inclination of EP. This is EP, guys. So these are the positive x-axis. This is what I was talking about earlier. If these are the positive x-axis, the angle that you're looking for is this angle here. This would be your theta. But you can clearly see that this line EP, it's going to have a negative gradient. We talked about this in earlier grades, in grade 9 to be exact. That a line that touches the second and fourth quadrant has got a negative gradient. Now, if you find the gradient for this one, you're going to get a negative gradient. I hope you've already paused the video, tried to do the question, and then you're looking at this now after having paused this video. Now, tan theta is equal to the gradient of EP. Then you first find the gradient of EP, which will simplify to negative 1 over 3. Now from this one, you can use this formula here with theta being 161.57. If you use a calculator, so say second function tan of negative 1 over 3 or shift tan of negative 1 over 3, you get negative 18.43. But I did say earlier on that if you find a negative angle, just add 180 to it. So you arrive at 161 0.57 degrees. That is theta. Now, to find E1, guys, to find E1, it means your 161.57, it's this angle here. I've already told you that. Now, this angle, if you look at this triangle, this will be the exterior angle with D and B1 being the opposite interior angles. So, at some point, you're told that in grade 9, actually, you're told that the sum of the opposite interior angles is equal to the exterior angle. So this is what we used actually here. Hence why I wrote there is an exterior angle of a triangle. So we arrive at beyond being 71.57. The last question, it says determine the equation joining points C and E. So if you want to find the equation joining point C and E, let me show you the diagram one more last time. C and E